Okay, I'm sure question number 18 will definitely feel easier if we just replace these angles theta and phi just by the letters A and B. So what I'm going to do here is just to replace these two and say it is given that the angle A, pi over 4, and B in that order are in arithmetic progression. Okay, so we are given that these are the three terms in an arithmetic sequence, and we are asked to show that this equation is equal to a constant. So since I replaced these two by A and B, so I just type this out here in terms of A and B. So we are trying to show that this trigonometric expression here will simplify to give us a constant term. So we'll first start with the fact that these three terms are in arithmetic progression. So an arithmetic sequence is one where we start with some number and then add a constant term to get the next one. So the common difference. The way we find the common difference is we take the second term minus the first term. So we could say pi over 4 minus A will give us the common difference. But another way to get the common difference is to do the third term minus the second term. So this should be equal to B minus pi over 4. Right? If we then do some rearranging here, I can add A to both sides. So if I bring the A to the right hand side, I'm going to have A plus B. And if I add pi over 4 to both sides, pi over 4 plus pi over 4, we get A plus B is equal to pi over 2. So in terms of the three terms being an arithmetic sequence, I don't think there's much else we can do here except to show that A plus B is equal to pi over 2. Right, so we'll then have a look at this trigonometric expression, see what we can get if we expand that. So if we expand the brackets out on that one, so sine A minus sine B squared, that is going to be sine squared A. The middle term will be minus 2 sine A sine B. And then minus sine B squared will give us plus sine squared B. So that is just the first bracket expanded. So that is just this part here. We can then expand this in a similar way. If we expand that bracket, we are going to have plus cos squared A plus 2 cos A cos B, and then plus cos squared B. Right, so if we look at this one and see what we could simplify, these two terms here, so sine squared A plus cos squared A, these two will add up to give you 1. And then similarly, the sine squared B plus cos squared B, that also adds to give you 1. So in this case, we have these two terms. So these four terms altogether will give us 1 plus 1. So that's equal to 2. We then have, I'll write that term next, which is plus 2 cos A cos B. So we have plus 2 cos A cos B. And then this term here, which is minus 2 sine A sine B. Right, so it's at this point where we just kind of have to recognize this form here is that it looks something like a trigonometric identity that we might use. So it might in fact help to rewrite this part as 2 times cos A cos B minus sine A sine B. Right, so even if you are somewhat vaguely familiar with this identity here, or if you look at this and think, oh, there is some addition formula that gives you this. So if you look at this expression here and look this up in the formula book, what you find is that this is equal to, this is just simply cos of A plus B. So what we have here is then 2 plus 2 times cos A plus B. Right, so what we are asked to show is that this whole thing just simplifies to one constant k that we are asked to find. Now we showed using the fact that these three terms are in arithmetic progression that A plus B is pi over 2. So then we can replace this A plus B here by just pi over 2. So this becomes 2 plus 2 cos pi over 2. So if you plug this into a calculator, so cos pi over 2 is equal to 0. So this just gives us 2 plus 2 times 0, which is then equal to 2.